We are almost at the finish line, as this is the last video that we're going to do. Before we do the coding, let's explain a little bit what this code does. So in order to do this, I'm going to freeze panes under View, then choose this option, Freeze Panes here. And what it will do is it will block my window. So if you now scroll right, you will see that column J is always going to be visible. So let's scroll to the right and find for row number 7 this departure time, 0510. So by scrolling right, 0510, and we'll find it under column RS. So what we want these cells here to represent are the number of passengers coming into our terminal. So what our code now needs to do is find this value, 5 hours and 10 minutes, and find the same value in the top row in our worksheet. And it will do so under column RS. So essentially 150 cells to the left, we want VBA to print our distribution patterns array and multiply this with the numbers that we put under the seats array. So 5 hours and 10 minutes minus 150 minutes is 2 hours and 40 minutes. And basically the array needs to start or needs to be printed. So our array needs to be printed under column LY to start at 2 hours 40. And this is just the example for this one particular flight. So I'm going to unfreeze panes and move back to the VBA editor. So let's start by declaring my output array here. And I'm going to make it a dynamic array as variant as data type. Later on we will see why that is. And here then I'll start with a redim statement for output array for 1 to the number of rows on the one dimension, and on the other dimension I'm going to size it from -150 to 1439, also as variant. Then I'm going to go through a loop for I is 1 to number of rows, and I'm going to set a new variable that's going to be called time index. What that does is in a certain range it's going to find a value for EOBT and then return me the column number. So this is the code for it. So starting from the top row in FU1, so that is midnight, until the end of the array, which is BJD1. And I'm going to ask Excel to find a certain value, and that value is EOBT array and whatever is under the value I in my loop. And for this particular function, I need to specify VBA that I'm going to look for a whole number, and I want it to return a column number. So what this code does is it's going to find the value EOBT array. So for example, 5 hours and 10 minutes in this particular range from FU1 to BJD1, and that it's going to find in a certain column number, and it's going to give me that column number. But like I said, we don't actually want this column number. However, this is the column index number in the worksheet, and therefore the offset is not 150, but it's 328. And later on we will see why that number is correct. So while I'm still in my for I loop, I'm going to start a for j loop for 1 to 150. And I'm going to write my output array. And it's going to be formed by 2 dimensions, I and j plus the time index. And what that does is find the distribution patterns for row 1 to j, so that can be 1 to 150, and multiply that by the seats array, whatever value we find in row I. Here I'm going to call for next j, and here I'm going to call for next I. Now I need to print this range to cells 227 and cells 2 plus number of rows. then all the way to the end until 1616, and that is going to be output array. Also, before we run this code, we need to do a quick fix of something that we did earlier. In the redimensioning of the EOBT array, we're going to set it from 1 to number of rows, and the loop is going to go from 1 to number of rows. And we're going to add 1 under I. And we're going to do this very same thing for the seeds array. It's going to start at 1, and the for loop is going to be from 1 to number of rows. And again, I is +1. Okay, switching back to the worksheet, I'm going to do a little trick in the arrival distribution patterns. So note that 150, there's 0%. So later when I want to check the position of the output array, I want to make sure that there's a number in there. So I'm going to go for 10%, and this is just for testing purposes. Later I will reset this number to 0. So now I'm ready to, for the first time, I'm now ready to run my code and see what it does. So for the first time, I'm ready to run my code. Okay, so I ran the code for 100 lines. Now go back to the worksheet and see if this worked. And let's just quickly do a spot check for the scale flight that is in row number 7. So we're going to go for row number 7. And remember that we're expecting to find this somewhere under 2 hours 40. Yeah. So here's 16, which is 10% of 160 passengers. And scrolling to the right. So the departure time for this flight is 5 hours 10 minutes. We're expecting to find 176 passengers. Remember that I added 10%, so this is 110% of 160, which is very nice. So I'm going to reset this to 0%. Let's do some cleaning up of the worksheet. I still need to dimension time index. As a single, and I need to leave some comments here. So find the column index number and offsets this for 150 columns, and this for j loop multiplies the distribution pattern with the number of seats. And this here prints the output array to the worksheet. Okay, let's also make sure to save our code. Okay, that's now done. Okay, so now that I've done my checks, I'm confident to run this code for all 160,000 lines. So I'm going to put that in here and press OK. Okay, so I've tried to run this code, but after a couple of minutes it gives me an out-of-memory message. Maybe your processor and memory are powerful enough to run this code, but my laptop sure is not. So I'm going to break up my code so that I can execute it in 2 sections or in 3 sections or even in 4 sections, or your laptop if you run into the same problem. So this is not necessary if your computer is powerful enough to do it at once. But if it isn't, then you can follow along and adjust the code as follows. So I'm going to add a new variable that is going to be called start row. And similar to where I ask for the number of rows to execute, I'm now going to ask the user to set the start row. So the start row is going to come from an input box, and please fill out the row number to start. this code. And so basically this is going to be I plus start row now, and we need to offset it for 1, and we need to do the same here, plus start row minus 1. And all the way at the bottom, when printing the sheet, we need to adapt 2 to start row. And start row here as well. There's one more tweak that I made into my code, and I made a correction earlier. So note that when printing your output array onto the worksheet, it should print the number of rows minus 1, just to avoid any not available comments into your worksheet. Otherwise it will print n/a for not available. So now I'm going to run my code. 1000 rows from row number 2 now. So let's have a look at my KLM flight. It is on row number 7 that I know that it's starting from 240. And so this should sum up to 160. And it still does. So this code is still fine. So I expect it to stop at row 1000. Which is here. And I ran the code from row number 2 and then up 1000, and therefore my code stops in row 1001. So now let's do the second part of this code from row 1002, and then let's add another 2000. So I'm going to run this code for 2000 lines now, and I want to start from row 1002. Okay, so it's run my code, and starting from 1002. So this is by coincidence again a flight to Amsterdam. This time it's Alitalia, and its estimated of blocks time is 5:01, and it has 185 seats. So let's scroll to the right. And exactly 150 cells. So from 5, remember it was 5:01. I'm finding the passenger values here. This is the last one, and it sums up to 185, as you can see here in the bottom. So that code works fine too. So depending on your processor and memory, you can now start to execute the next chunks of rows in your Excel sheet. And on my computer, it's fair to say that it's capable of doing 70,000 to 80,000 lines at once. It's just that I cannot reach the full 160,000 in one attempt, so therefore I need to break it up. Notice that there are still a couple of challenges here. I've used the seats array in my video, and so I used a full 100% load factor of these seats, which is of course not realistic. So you need to make small adaptations to this code to still get a realistic load factor on these flights. And also notice that if you're not happy with the amount of detail in this code, then you can add distribution lines for charter and low-cost airlines. So remember that the code for this is already in here. We even have the first 4, so you can add another one other than LCC and charter. But at some point you'll have to tell VBA what distribution row to take, either 1, 2, 3, or 4. So that's another challenge to get this code working and make it more realistic too. Also, when you have the entire code working, one of the challenges that you're up for is that you will want to calculate the sum of these clock hours, so from midnight until 00:59, and then all the values that are underneath for the first day. So this is for January 1st on 2016 until 00:59. You will want to sum up the values that are underneath. So this is a pretty slow hour as there's only 4 flights generating traffic. So the sum of this clock hour is 71 in total. 71 passengers go through the terminal. And again, you'll want to do the same for the next clock hour, so from 1 to 1:59 and so on. And then you will want to do this for every clock hour of every day. So you will need to figure out a way of how to do this, either using VBA or using functions in Excel. Okay, so that's it. I hope this code works for you. Leave your comments in the comment section below if you have any questions, and I wish you best of luck.